All right, welcome everybody. I'm Mr. Hulsey. This is Dr. Zhang. Dr. Zhang was my friend from college. We studied biomedical engineering together, and now she's a PhD data scientist at Expedia. Is that right?
Yes.
Awesome. Well, I'm going to sit back and let you guys do most of the I'm calling this an industry interview. I'll let you guys ask her most of the questions, but I guess we can start off by Dr. Zhang just telling us about your job, your career. Tell us about you.
Yeah, I think I can introduce a little bit more of my own background. So in 2020, I got my PhD degree in biomedical engineering. During my PhD, my research focus was using images and some optical spectral data for skin cancer diagnosis. Like we use instruments to shine light on the skin, and we collect the optical data, or we capture the image. And then I build some models to analyze whether the measurement is cancerous or not, or what type of cancer it is. So that was my main work during my PhD program. During my PhD, I had 2 internships at Dell Technologies. I worked as a data scientist intern there. I was building forecasting models. So given the historical data, my model was supposed to predict how many, what's the demand for their computer parts. So how many parts they need to buy for the next quarter or next month or even next week, to help with their planning. For my own technical, educational background, I studied learning programming in high school. At that time, I was learning a very, very old language called Pascal. I don't think any of you know that language. It's too old. Nowadays, I don't think anyone is using it.
Mr. Mickle. Mr. Mickle probably knows of Pascal.
Oh wow! Oh, that's cool. Yeah, then I went to college in China, Shanghai Jiao Tong University. It's it's an engineering school, university. I learned MATLAB, Python, C++, multiple commonly used languages there. And during my PhD, I realized I really want to use some computational methods to solve any meaningful problems. It does not have to be in biomedical field if there's no perfect fit. So when I was looking for a job, I got a offer from Expedia. I found it very exciting. So Expedia is a traveling company. All the things we do is to help people make people have an easier process to plan for traveling. I force the traveling related to biomedical because I think traveling is good for mental health. It's somehow related to health. Yeah. And currently, I'm mainly working on natural language processing field. So if you go to any website, traveling website to book a hotel or rent a car, then you have the chance to chat with a robot on the website. So the chatbot needs to understand what you type in your message. And I'm building the model in the backend to understand your intent and provide some relevant and helpful responses to any message users will type there. Yes, so hope this is not too long. So that's the general, yeah.
Yeah, that's awesome. So like I said, I'm just going to let you guys ask Dr. Zhang some questions for the rest of the time. You can definitely use the chat or unmute yourself, either way.
Oh, so I saw the question, do you use TensorFlow? Yes. Yeah, we use TensorFlow. Yeah, I was using TensorFlow to build. Sorry, let me answer the questions one by one. So so I was using TensorFlow to build the language understanding, the natural language understanding models here at Expedia. The most commonly used model is the intent classification model. So for any message we receive on the chatbot, we need to identify what intent it is. Maybe it's to book a new hotel or book or cancel a booking or change a existing booking or any other intents. I was working on the classification models, and the framework I use to build the model is TensorFlow. We also use PyTorch. They are like they can. I mean, if I can use TensorFlow to build the same model, then I can use PyTorch to build exactly the same model. So either framework will be okay. So let me read the chat. Yeah, so TensorFlow is the very commonly used framework to build any machine learning models. Yeah, that's very helpful. It's very easy. I mean, the current framework makes it very easy for any users to use. They make any function as an API. You just need to know what you want, then you find the API to do the exact function, then provide the correct format as the input, then you can get what you want. That's the basic idea of using them. Yeah, let me know if you have any more specific questions. Yeah, for Dialogflow, I used it during my PhD. At that time, one undergrad student was working with me to build a chatbot to do some motivative interview for children who have some issues with their teeth. So we use the Dialogflow to build the chatbot to mimic the chatting with the between the children and the doctors. Yeah.
Is that like a natural language processing framework?
So the Dialogflow is a platform for us to build a chatbot easily. Like, we don't even need to know much about coding. We can just use the user interface to use the mouse to click something to make a chatbot there, and you can deploy the model, the chatbot to Slack or Facebook Messenger. Yeah, it's cool.
Oh, nice. I've never heard of that. That's awesome.
Yeah, if you take some time to play with it and follow one example, then you will see how it works.
Gotcha. Okay, yeah. So then you said, which courses did you take in high school? I guess that's particularly engineering or computer science courses, right?
Yeah, so I think the Chinese education style might be a little bit different from the education in the US here. So when I was in high school, we were mainly focusing on preparing one exam to that one exam has the is the most important thing for you to enter the universities. So for that, we study all kinds of subjects. Yeah, including we didn't have a chance to select other like optional courses. How about you? I don't know. What's the current status?
Yeah, we have a bunch of electives really. We've got like these guys are all taking my computer science principles course. So that's the freshman level. We have 4 years at least for computer science courses. We're about to add a mobile app development course next year. And then we also have 4 years. We have more than that. We have 5 or 6 different engineering classes. You can take all of those during high school. So that's really special, I think. So it sounds like in China you didn't have those options in high school.
Yeah, I think it's too different. Yeah, the high school is too different. I don't think my experience in high school is any helpful. Yes, so
But you said you did some programming in high school, right? Was that kind of on your own?
oh yeah, that is a special thing. Like for example, in my high school, in my grade, there were like 1,000 students in the same high school, and only 10 students may study the programming because we were attending the Olympic competitions in informatics. Like we were kind of selected to study something to compete. So that was not very common. Yeah. But yeah, that I think that was very helpful for me because I realized once I understand one computer programming language, it made it very easy to learn any other new programming languages. Yeah, because the logic, the algorithm are very similar. Yeah. Yeah, how about we go to the next one?
Sure. So Niti said, how do you go about analyzing the images for your skin cancer research? Yeah, that's a really interesting question too. What types of
Yeah.
software?
So when we got the images, we had mainly two approaches, like two big different approaches. One is using feature engineering methods, like we crop the, so there's a lesion in one image, right? We will write a programmer to crop the image because the image is usually in the center of the because the lesion is usually in the center of the image. So we crop it and we segment the lesion itself, and we will calculate some features of the lesion, like like asymmetry, the border irregularity, the color variation, the size. So we will use like we will use some meaningful features and build a say linear regression model to predict the risk of being melanoma of each lesion. So that's one way, like we need to define what features we are interested in or what features could be useful. And this model is more interpretable. Like we can explain like how it works, what features are contributing to the output. And the other approach is using purely machine learning models. So we use the pre-trained neural networks. So there are some existing neural network models. They can identify the image as a like dog or cat. So the model was trained to learn something in the images already. So we used the idea of transfer learning to teach the model to identify whether it's cancer or not in our model, like for our skincare research. So that was the two main ideas. Hope this makes sense. Does it make sense to you?
So really, when a doctor learns what is skin cancer and what isn't, they're looking for the same features, right? Is it red? What color red is it? Is it big?
Oh yeah, I can actually introduce the commonly used features for dermatologists. It's very interesting and it's very easy to remember. That's a commonly used A, B, C, D, E rules. So A stands for asymmetry. So if the lesion is more asymmetric, then it has higher risk to be melanoma. Like B is the border irregularity. So if the border is very strange, is not like if the border is very irregular, then it has higher risk. C is color variation. If one lesion has like different colors inside, it has higher risk to be melanoma. And the D is diameter. If the diameter of the lesion is greater than 6 millimeter, it has higher risk to be melanoma. And the E is evolution. If the lesion changes as time goes by, then it has higher risk to be melanoma. So these are some common features doctors are looking for when they evaluate the lesions. Yeah.
So you mean the computer learns the same way that a doctor would learn?
Yeah. So we just wrote some programs. We wrote some programs to compute these features. So we can then use these calculated features to feed it to a, say, a linear regression model to predict the risk of each lesion to be melanoma. So in general, the whole pipeline is you have your data and you think about feature engineering, and then you will input these features to a model, right? This model could be the simplest could be a linear regression. You can also use some like neural networks as your model, and then your model is outputting like either the class or the score or probability if it's a regression model. Yeah, let me know if I mention any word you learn. Yeah.
Yeah, cool. I have a sort of a bit off-topic question. Is there any bias you think that goes into these algorithms? Like, for instance, when you're talking about skin cancer, I'm sure the color of the lesion is going to be different for different races, right? Different base skin tone. How do you? Is there any way? Would you say there is bias inherently in the algorithm, and how would you go about removing that bias if possible?
So you are questioning about the background of the skin. They could be different. They could have different colors. So yeah, we had one like pre-processing to calibrate the colors to remove the impact of like the light environment or the original color of the skin. But our data were collected in the clinic in Austin, so actually the most patients we got were in white. So that was not a big concern in our data set. Yeah, but that's a very good point. Yeah. So the type of software I used I was mainly using MATLAB at that time to do the image processing. And I also used the R to do some statistical analysis. So I think the next question, Google Assistant thing, right? I think you're asking like the chatbot you are building, or
Wait, no, that wasn't a question. I just typed it before, like a really long time ago when you're talking about something.
okay. Do you remember what I was talking when you was thinking about that?
Oh, on Dialogflow. Well, that's still a relevant question. I think in all of your applications, Dr. Zhang, you have, correct me if I'm wrong, but it sounds like you have the opportunity to use existing or open source models and then retrain them.
Yeah.
And is that always what you choose to do, or can you start to use other models or create some from scratch? I think that was Rishik's question.
Yeah, we don't if there's a existing model that we could use to start, we would prefer that. So I like to think the model training as teaching a student, yeah, we can choose a baby that did not know anything, but it's very helpful if that student already learned something, and if I'm training this student to learn a new skill, it will be easier. I don't need like big data to do that. Yeah, this is especially the case in the field of natural language processing. So I think starting from 2018, natural language processing developed a lot faster than previously, because Google trained a big model so when they train the model, they use all the data on all Wikipedias. So they have huge amount of data set, and they use the tasks. One is masked word. So given one sentence, they will mask a word or two words, and then let the model guess what's the masked word. And the other task they trained the model to do is, given two sentences, the model needs to say whether the sentence 2 is the next sentence of sentence 1. These tasks are designed to train the model because we don't need to label the data. Like any given existing text online on internet, we can use them to do these training tasks. So they trained the model called BERT, B-E-R-T. That's the basic model we always use as a baseline to train any kind of natural language understanding model in any new domain or any specific use. Because this model has some existing understanding of languages. For example, what it does is to convert one sentence or one word to a mathematical vector. For example, given the king, we can get a vector. Given a queen, the word, we also get a vector, right? Because they are somehow related, because they're a couple, right? So these vectors in the math word, they're closer than other unrelated word pairs. So we always start from pre-trained models to do some new task training.
That's crazy. You mentioned that last time we were talking, Dr. Zhang. So it sounds like that one model, the BERT model, is really versatile. You can use it in lots of different applications.
Yeah.
That's crazy. Do you think that model could also, what I'm really interested in lately is what kind of phrases are used in what kinds of contexts and by what kinds of people? You know, like in the news lately, you know, some people say certain words to be more assertive or more aggressive in their speech, you know, condemning a certain group of people, or you know, not condemning them as strongly or something like that. Whereas some words are less harsh, you know. So could the model do that sort of analysis, kind of figure out in what context people are using harsh language?
Are you talking about the sentiment, or are you defining? Do you think what you mentioned is kind of related to sentiment, or not?
Yeah, I guess so. I haven't really fleshed out what I'm trying to think about. I'm just kind of curious, seeing certain words in certain contexts. So I guess, yeah, sentiment. I guess you'd have to really well define what sentiment you're looking for first, right?
Yeah, so the very commonly used sentiment classification model can tell you whether the given sentence is positive or negative or neutral. Or if you define different levels, it can also predict the level of, like, it's very positive or slightly positive or neutral, slightly negative or very negative. So you can define the labels, and if you have the data, then you can train the model to identify the different levels of sentiment. Yeah, so what
I'd imagine that. Sorry, what did you say?
Oh, I was saying, so the question you asked, that could be trained in a similar way.
Gotcha. Yeah, I was gonna say, I'd imagine at Expedia with a chatbot, you would really want to be aware of who's really angry, right? And take those angry people and give them a real person, probably. And that's what I do sometimes when I'm talking to a virtual assistant. I say, agent, I'm going to talk to a person. But I feel like Alexa is really good at that sometimes. When I say, Alexa, stop, she can really tell that I want her to stop right away. You know, do you think there's machine learning going on there?
Yeah, we have the sentiment detection built in our model. Yeah, you are right. We have a logic there. If the message is very negative, we don't think the virtual agent will handle that. Then we will let a real human being agent to talk with the customer. Yeah.
Cool. Sorry, I told y'all that I would let you ask all the questions, but I just got so interested in it. Let me sit back. I think we're kind of coming to a close anyway. We'll wrap up pretty soon. But let me sit back and wait for a few more questions from you guys.
Yeah. If there's no questions, I can show you a like open source website if you want to like just simply try some existing examples of some natural language processing models.
Oh yeah, that'd be great.
let me see. How could I share my screen? Okay. Present now. Okay, I think I'm trying to share my screen. Is it working? Can you see my screen?
I see it. I see it says Zhang is
So
presenting.
it's a GitHub
Looks like
page.
your icon again. Do y'all see it? I'm on my phone.
Can you see the GitHub page?
Sorry, what'd you say, Dr. No, I don't see the GitHub page. Do y'all see it, Rishik and Ayush?
I just see it say presentation.
So
Yeah, on Google Meet, it's kind of weird. You have to click a few things to make it work.
so it's not showing the page I want to share.
So there it is. I see it now.
So what you can see, transformers, right?
Yes, on GitHub.
Yeah. So yeah, in natural language processing world, all the models have very fun names, and the one very popular thing is called transformers. It's a technique used in natural language processing to help the model understand the context better. And if you go to GitHub Hugging Face transformers, you can see all the state-of-art natural language processing for PyTorch and TensorFlow too. You may not need to go to very technical, but there are some online demos that you can get a sense what does each model do. For example, if we go to, say, text generation with GPT-2, if I type a long time ago, then the model will be able to continue like with some random stuff. And you can type anything you want here. So like after pandemic 2020. So you can see I just typed after pandemic in 2020, then it continues with some that could make the economy going low into the second term or to the last. So it's very interesting. that's what a language generating model can do. It mainly predicts the next word. So it keep predicting the next word to complete a sentence. Yeah.
I could definitely use this if I am, writing a story or a poem, and I get mind blocked. I can just come in here and see what it's trying to predict for me. That's awesome.
Yeah, and also there are some like translation or question answering, like summarize. Yeah, you can play with these demos and to see, oh, what the current status of the existing NLP models can do. Then you will be amazed how the computer understands our language like at the current moment. Yeah, that's the current state. Yeah.
That's really cool stuff. I might just spend hours and hours on this coming up in the future. Can you give us a link to this?
Yeah.
Yeah, put the link in the chat. That'd be awesome.
So, yeah, put the link in the chat. you can go very technically, and you can download the code and even modify the code because it's open source. But just to get a taste, you can just try their online demos and to see how their existing models look like.
Awesome. I'm glad this stuff is open source. I think we are just, as a species, adding to our collective knowledge using that open source idea. Really neat. So yeah, I think it seems like the questions have kind of tapered off. Maybe we'll wait a couple more minutes for more questions, but thank you so much, Dr. Zhang, for taking your time. You didn't have to come. You're not getting paid for this or anything, so we're super appreciative of you showing up and offering your time and your expertise to these students. These kids are really, really interested in computer science and the next hot thing, which data is really hot right now, and AI is really hot right now. So you're combining those fields in a really interesting manner. Maybe some more of my students would like to hear more from you in the future. So I'll get with you again. I guess I'll distribute this video to my classes, and then I'll see what they think about it. And then maybe if they want you to come back, then I'll ask you again for another talk, or maybe a more specific talk, or a demo of your code, or maybe a code through. I bet they would like that. The students who have some understanding of PyTorch or something like that, you could walk them through some of that code. But yeah, anyway, thank you so much for volunteering your time on the talk so far. It's been excellent, very informative, super, super interesting. I think a lot of kids are going to be really passionate and interested in AI, natural language processing, and data science as a whole after hearing this. So thank you again.
Yeah, you're welcome. Yeah, let me know if your students have any more specific questions, and you can send them to me. Yeah.
Okay, cool. We certainly will. Like I said, I'll give this video to my students, and then they'll be able to come back and give me those questions, and I'll send them over to you.
Okay. Yeah, sounds good.
Okay. Well, thank you very much. I'm going to stop recording if I can.